You ask ChatGPT to help pick a programming language for your project. It suggests something. You say no. Give me something more modern. ChatGPT switches the stack. The project doesn't launch for 3 months. That's what the wrong language choice looks like on a first project. Last time we built the first step, a landing page to collect signups for your future product. One prompt, one command, done. Today, the foundation. Skip it. And AI codes blind. How a web request works under the hood. And how to pick a programming language so you don't rebuild the project in a month or two. At the end, there's a conclusion that goes against most advice you'll find online. This is lesson 2 of the course on launching apps from scratch. Web fundamentals, architecture, and language choice. My name is Eugene. I've been in development for over 20 years. This course is free. Links to all lessons in the description. Quick question before we start. Drop a number in the comments. Have you already picked a programming language for your project? If yes, but you later regretted it, type 1 if you haven't chosen yet and you're waiting for real advice. Type 2 if you had no idea this decision happens before you start building. Type 3, 2 blocks in this lesson. First up, how the internet works under the hood. What actually happens when a user opens your site? Browser, DNS server, code. Most vibe coders skip this part. Then the app is done, works locally, but it's not on the internet. Second, picking a programming language. What languages exist for web development? Why some are better for vibe coding than others? And how to make that choice consciously. Not just follow what ChatGPT suggested. Watch to the end, you'll get a clear answer. What to pick at the start and why. Get this right now, save weeks later. Let's start with the basics. Every website on the internet lives on a server. A server is just a computer. Always on, always connected. Each server has an IP address. It's a unique number, like a phone number. For example, 142.250.7446. Here's how Google looks from a network perspective. When you type google.com in your browser, the browser doesn't know where that site is physically, so it goes to a DNS server. DNS stands for Domain Name System. Think of it as the internet's phone book. You tell the browser, open google.com. The browser asks DNS, what's the IP for this domain? DNS responds, 142.250.74.46. The browser goes there. That's the full path from address to server. This happens every time you open any site. Takes milliseconds. You don't notice it. But the moment you buy a domain and want to point it to your server, that's when you'll need this. Because you'll be the one creating that DNS record. You tell the browser which IP to send requests to. How this works in practice during deployment, that's a separate video. Links to all lessons in the description. One more thing. Multiple projects can live on one server. The IP address belongs to the server, not the project. One server can host 3 different sites. How that works, we'll get to it. Subscribe for the next lesson on your dev environment. Without it, code from a chat won't run in a browser. Drop a like up front. If the video turns out useless, you can take it back. A request hit the server. Now the server needs to respond. On the server, a program runs constantly. It's called a web server, not the physical server, a program inside it, usually Nginx or Apache. Its job, accept incoming requests from the internet and decide what to do with them. The web server looks at the request and makes one of 2 decisions. Option 1, a static file was requested, like an image, a font, a CSS file, an icon. Those files already sit on the server, ready. The web server grabs them, sends them back to the browser. Directly, nothing runs. Nothing gets generated, just a file copied from a folder to the browser. Option 2, a page that needs to be generated, a newsfeed, a dashboard, search results, dynamic pages. Each user has their own data, their own records in the database. There's no ready file. It has to be built right now. In that case, the web server passes the request forward to a process manager. The process manager is another program. Its job, run your code. The code written by the AI. PHP, Python, JavaScript, or whatever language you're using. The code gets the request, figures out what page was asked for, goes to the database for the right data, builds the page, and sends it back. Process managers have different names depending on the language. For PHP, PHP-FPM. For Python, Gunicorn. For Node.js, PM2. Different names, same job, run the code. The full chain looks like this. Browser, DNS, server, Nginx, PHP-FPM, your code, database, response back. That's the full request path. At each step, something can break. When a site doesn't load, it's not always the code. Sometimes it's DNS, or Nginx, or the process manager. Know the chain and you fix bugs in a minute. Skip it and you'll rewrite code that wasn't even broken. The server's response can take different forms, and that's directly connected to why you need a programming language. When the server builds a response, it decides what format to send it in. That depends on who's making the request. If the request came from a browser, the screen needs to show a page for a human. HTML is used for that. HTML is a markup language. It tells the browser, here's a heading, here's a paragraph, here's a button, here's an image on the left. The browser reads it and renders the page. That's what HTML looks like. The server built it and sent it to the browser. If the request came from another app or server, not a browser, it doesn't need a visual page. It just needs data. For that, JSON is used. JSON is a text format for transferring data. Curly braces, keys, and values. No buttons, no styles. Just structured data. When your app connects to a payment system, a Telegram bot, or any external service, everything goes through JSON. That's why you need to understand this now. When you give a task to the AI, you need to know what you're building. A page for people or an API for integrations. That changes what gets built and how to test it. Building a page for users and building an endpoint to return user data are different tasks, even if the underlying data is the same. Now let's talk about stacks. LAMP, MERN, MERN are stack abbreviations. A stack is just a set of technologies that run together on one server, like a kit. LAMP breaks down like this. Linux is the server's operating system. Apache is the web server, the one that accepts requests. MySQL is the database. PHP is the programming language. The full chain. Linux runs Apache. Apache accepts requests and passes them to PHP. PHP gets data from MySQL and responds to the browser. This is the stack that's powered more than half the internet for the last 20 years. MERN is a JavaScript stack. MongoDB is the database. Express is the framework. Angular and React handle the front end. Node.js runs server-side JavaScript. One language, JavaScript, on both server and browser. MERN is the same thing, just with React instead of Angular. You don't need to memorize these abbreviations right now. One thing matters. When AI writes code, it writes for a specific language. PHP code won't run on a Python server. Python code won't run on a PHP server. The server needs exactly the software your code requires. Choosing a stack means choosing the whole set at once. That's why this decision is made once before development starts. So what should you pick? Python, the most popular language by search trends in 2024-2026. Clean syntax, low barrier to entry. AI writes it well. Yeah, there's more training data for Python than any other language. Good for web services on Django, for APIs on Fast API. Extra bonus, if you plan to work with AI models directly, Python only. Training, fine-tuning, local models, all Python. Next, PHP. 3/4 of the internet runs on it. Built specifically for web development in 1994. Simple syntax, low barrier, massive ecosystem of ready solutions. Lots of developers, relatively affordable if you later need to hire. Downside, losing market share, ranks low in surveys, but products built on it work. JavaScript, that's Node.js on the server. One language on both front-end and back-end. Sounds convenient. In practice, it's a trap. JavaScript adds complexity, async patterns, its own ecosystem, a different way of thinking about code. AI handles it well, but the front-end side gets messy. Next.js is very popular, but it leans toward a React front-end rabbit hole you can get stuck in for a long time. Go. Popular for high-load services and microservices. Compiled, fast, concise, but fewer libraries out of the box, harder to get started, and less AI training data. Building your first SaaS on Go adds complexity where you don't need it. Developers are harder to find and cost more. Ruby on Rails. Legendary for speed at launch. True, Rails lets you build an MVP fast, but the Ruby developer market is tiny. If you need support or a hire later, you'll be searching a long time. Ruby ranks near the bottom of most surveys. Let's look at this from another angle, the hiring market. Your language choice isn't just about now, it's about a year from now when the project grows. There's one practical criterion most people miss. Don't look at popularity rankings. Look at ecosystem size, how many developers are on the market, how many ready solutions exist, how well AI is trained on that code. According to Stack Overflow surveys, JavaScript and Python consistently lead in active developer count. PHP is slightly lower, but the base is massive. 3/4 of all working sites in the world. Ruby and Go, the developer market is several times smaller. What that means for you, if in a year you want to hire someone for support, Python and PHP are easy to find. Ruby and Go, you'll search longer and pay more. That's a practical criterion, not an aesthetic one. If you ever want to sell the project, complications there too. Your exotic language means finding a buyer who's also into that exotic. No reason to shrink your pool of buyers. Criteria for your first project. First is simplicity. Don't complicate things at the start. Only about 10% of projects make it from idea to launch. Add a hard language choice on top of that, and the odds drop to near zero. Second is speed. How fast can you get to a working version? Third is finishing probability. Writing 90% of the code isn't hard. The last 10%, getting to production, that's where most people stop. Fourth is handoff potential. When the project grows, how easy is it to find someone to take over support? By these criteria, two choices stand out. Want to build and ship a real project? PHP. Max ready-made components out of the box. Auth, routing, payments, queues, deployment. Tons of docs and examples. AI knows it well. 3/4 of the internet runs on PHP. Solutions for any task already exist, more than you'll ever use. Working with AI models directly, parsing, analytics, training, Python, plus Django or Fast API. Also excellent for API integrations. One clarification. Working with AI models means building or training actual models. Calling ChatGPT or any LLM via API. That's not AI work, that's API work. In short, want problems in the future? Pick Ruby or Go. Want problems right now? Pick Node.js and Next.js. Want things to work from the start? PHP or Python. In this course, we work on PHP, the one-shot framework. I built it specifically to speed up SaaS development with AI. More on it in the next lessons. It's free and open source. Everything on GitHub, so you don't start from scratch. Link in the description. For your own project, choose based on your task. Here's what we covered. How a request travels. Browser, DNS, server, Nginx, process manager, code, database, response back. At each step, something can break. Now you have the map. 2 server response formats. HTML for people, pages in the browser, JSON for machines, data for integrations. A stack is a set of technologies that work together. The choice is made once before development starts. And the language, for most projects, PHP or Python. Everything else is either more complex or the market is small or both. Next lesson, Claude Code and your dev environment. How to set it up, how to give tasks, how to manage context. That directly affects what you get from the AI. Link in the description. If you want to do this with your own project and don't want to figure everything out alone, I help. I review architecture, go through prompts, work through tasks together in the community. Link in the description. If you take away one thing, don't look for the best language. Look for the language where AI writes well. There are plenty of developers, and the framework gives you everything out of the box. That's PHP or Python. Everything else is marketing. One last question. Have you chosen a language yet, or still deciding between 2 options? Drop it in the comments. What you picked and why, I'll reply to everyone.